Suppose our glider starts at the top of a mountain at the coordinates 0, 1250. Its x-coordinate at time t is given by x is 2t, and its y-coordinate at time t is given by 1250 minus t squared over 2, and this is for t between 0 and 50 seconds. When we write x and y like this, we say they are parameterized by t. We want to plot the trajectory, the path that the glider takes, and we want to calculate its velocity. Calculating the velocity when x and y are written like this is easy. We just differentiate with respect to time so that x dot is equal to 2 and y dot is equal to minus t. To plot the trajectory is more difficult since we want to plot a relationship between x and y with no t in sight. It's not that hard though in this case. We just eliminate t by writing t is equal to x divided by 2. So that means that y is equal to 1250 minus an eighth x squared. So our trajectory is just a parabolic path starting at 0, 1250 and ending at the ground where x is 100. Another thing to note is that the gradient of the trajectory, dy by dx, which equals minus x over 4 in this case, gives the direction of the velocity, since dy by dx is equal to y dot divided by x dot. Let's consider a more complicated example. This time, x is given by 10 sine pi t by 5 plus 2t for t between 0 and 10 seconds, and then x is 2t for t between 10 and 60 seconds. Y is given by 1250 plus 100 times cos pi t divided by 5 minus 1 for t between 0 and 10 seconds, and 1250 minus a half t minus 10 all squared for t between 10 and 60 seconds. It turns out that the trajectory looks like this. We can calculate the velocity at any time in the same way by differentiating x and y with respect to t. Our problem comes when we want to write y explicitly in terms of x. For the first part of the trajectory, where the glider does a loop, it's very hard to see how we might eliminate t here. And this is because for certain values of x, we have 3 values of y. It is possible to calculate expressions where the relationship between x and y is not single-valued. A simple example of this is a circle, x squared plus y squared equals 1. But how can we plot a trajectory if we don't have a direct relationship between x and y? Well, we can use brute force. For example, when t equals 0, x equals 0, and y equals 1250. When t equals 60, x equals 120 and y equals 0. And if we pick enough values in between t equals 0 and 60, we can plot enough points in the xy plane so that we can join them up to get the trajectory that way.